Hi, my name is Brooke. Thank you for joining me to practice some math today. Today we'll be working on adding and subtracting polynomials. The word polynomial comes from poly, which means many, and nomial, meaning name or term. So a polynomial is a group of terms. So we'll see that polynomials can have different numbers of pieces. We will practice adding polynomials first, and the steps are to rewrite the problem. We'll stack the two polynomials up and rearrange the terms to make sure that the like terms are lined up together. And then step 2, we'll add up the like terms using our integer rules. So our first example shows us 6x squared plus 3x minus 4 plus x squared minus 7. So in step 1, we stack up the pieces that look alike. You might remember thinking about like terms as pieces that look similar and they have the same variable and the same exponent. So 6x squared matches with x squared. Same variable, same exponent. 3x does not have a match in our second polynomial. There are no terms that just have an x. But negative 4 does match with negative 7. Those look alike because those are just regular integers. So my next step is to stack up those like terms. 6x squared looks like x squared, so those stack up together. We leave some space under 3x since it did not have a match, and negative 4 and negative 7 look alike, so I stacked those up. Now that I've found my like terms, I can just add up the integers straight up and down. So I see 6, and then I do not see a number in front of our x squared. So if you do not see a number in front of a variable, remember that it's an invisible 1. We are adding up 6 plus 1 to get 7. Our 3x did not have a match, so I can just bring that straight down to the middle of my answer. Finally, we have negative 4 and negative 7. Since they have the same signs, they're both negative numbers, we can say same signs add. We add up the absolute values. 4 plus 7 gives us 11. And since they were both negative, we'll get a negative 11. So this is our final answer. We found our like terms, we stacked them up together, and then we added up the coefficients of our like terms. And the coefficient is just the number in front of a variable. Here is a second example. So this time we have 5x squared minus 5 plus x squared minus 3x plus 2. I usually like to stack up the polynomial with the most pieces at the top, but it does not matter how you show your work as long as you are lining up the pieces that look alike. So our 5x squared matched our x squared here, and our negative 5 matched our positive 2. Something to notice is that I am including the sign that's in front of the term when I make my shapes, and also when I am stacking up the terms. That negative sign is very important to get us to the correct final answer. So I stacked up 5x squared with x squared. Our negative 3x was all alone, did not have a matching term in the other polynomial. And finally, our positive 2 does match our negative 5. Those look alike, so I stacked those up as well. Again, in this problem, I do not have a number in front of my x squared, so that's an invisible 1. 5 plus 1 gives us 6, so we get 6x squared. Our negative 3x did not match anything, so I'm going to bring that straight down. And then we have a positive 2 and a negative 5. So we've got 2 plus negative 5. Those have different signs, so we can subtract the numbers. 5 minus 2 gives us 3. And then our higher absolute value has a negative sign, so our final answer should also be negative. So here's our final answer. We stacked up the terms that looked alike. We added, going straight up and down once we had the correct stacks. And we ended up with a final answer of 6x squared minus 3x minus 3. We will try out some problems together from start to finish. So looking at this problem, I see 4x squared minus x cubed, or x to the third power, plus 7x squared minus 8x cubed. So I need to stack up the pieces that look alike. I'm going to start by copying down my first polynomial. We have 4x squared minus x cubed plus 7x squared, and our 7x squared matches with our 4x squared, minus 8x cubed. So now that we have the pieces that look alike, we can add them up. 4 plus 7 gives us 11x squared. Here I have an invisible 1. This is like negative 1 plus negative 8. Since they have the same signs, we add the absolute values together. 1 plus 8 gives us 9. And both of our numbers were negative, so we do get a negative 9 as our answer. So our final answer is 11x squared minus 9x cubed. Here's another problem to practice. I'm going to start by copying down my first polynomial. 2 plus 8b squared. You are always welcome to use your strategy with drawing shapes around the like terms. So if you did that strategy, the 2's, or the 2 and the 6, those look alike. And then I see that our 8b squared and our 7b squared look alike. So you're always welcome to use that strategy if it helps you. Our 6 matched our 2, and our 7b squared matched our 8b squared. So I'm going to write plus 7b squared. This time we had to rearrange the terms so that I could get the matches in the same columns. 2 plus 6 gives us 8. 8 plus 7 is 15. So our final answer is 8 plus 15b squared. One thing you'll notice, especially as you're working independently, is that sometimes you'll get your pieces of your answer or the terms in a different order, and that is just fine. Another way that I could have shown my work on this problem is I could have written 8b squared first, 8b squared plus 2, matching with 7b squared plus 6. I would have gotten 15b squared plus 8. That means the same thing as this answer. So both of these are correct. As you work independently, your answers may look different from mine, but as long as you have matching pieces and matching signs, then your answer is also correct. Let's try out number 3 together. I'm copying down my first polynomial, 6 minus 8n squared. And then I'm going to stack up the pieces that look alike. I see a positive 7, so that's going to match with my 6. Next, I see a positive 5n squared. That matches with my negative 8n squared. They have the same variable and they have the same exponent, so those are like terms. I'm going to write plus 5n squared since our 5n squared was positive. Now I can add up my like terms. 6 plus 7 gives us 13. Negative 8 plus 5. Those have different signs, so we subtract the absolute values. 8 minus 5 is 3. And then our higher absolute value is negative, so we do get a negative 3. Negative 3n squared. So there's our final answer for number 3. Let's try out number 4. So I'm going to start by copying down my first polynomial. We have 6 plus 5m to the third power. I'm going to stack up the pieces that look alike. This time I see a negative 6. We always have to remember to include the sign that's in front of the integer. So I am copying down a negative 6. I see a positive m to the third power, so I'm going to put a plus sign in front of it. Now that I've matched up the pieces that look alike, I can go ahead and add. 6 minus 6 gives us 0. Next up, I've got 5 plus an invisible 1. 5 plus 1 gives us a positive 6. So, we usually do not show zeros in a polynomial. This is correct, but an even better way to write our answer is to just write 6m cubed. So this is our final answer. Both are correct and they mean the same thing, but we usually do not include zeros in our final answer. Let's try number 5. So on number 5, our polynomials are getting a little bit longer. We still do the exact same steps. So I'm going to start by copying down my first polynomial. We've got p to the fourth power plus p to the third power plus 5p. As I copy my second polynomial, I need to stack up the pieces that have the same variable and the same exponent. Even though I see lots of p's in my problem, I can only match up the ones that have the same exponent. So 8p to the fourth power matches with p to the fourth power. I notice that this polynomial does not have a term that has p to the third power. So I need to leave some space right here to show that I did not have a match. Next, 5p matches up with negative 4p. So I'm going to write minus or negative 4p. Last, p squared does not match with anything in our top polynomial, so that is also going to be written all on its own. We will write plus p squared. Now that I have everything lined up in columns, I can go ahead and add straight up and down. I do not see a number in front of this p to the fourth power, so it's an invisible 1. 1 plus 8 gives us 9p to the fourth power. The p to the third power did not match with anything. So I'm just going to bring that down to my final answer and write plus p to the third. Next, we've got a positive 5 plus a negative 4. Since they have different signs, we subtract the numbers. 5 minus 4 gives us 1, and our higher absolute value was positive. So we do get a positive 1 p. We know that 1s are usually invisible if they are in front of a variable. So we can write plus our invisible 1 p. Finally, p to the second power did not have a match, so I'm just going to write plus p squared. So this is our final answer. We talked about how all of the pieces can be in different orders. One thing that you'll see, especially in math textbooks, a more formal way to write your final answer is to write your exponents in descending order. So that means the numbers get lower as we go from left to right. So we can write it like this: 9p to the fourth power plus p to the third power plus p squared plus p. So our exponents are in descending order: 4, 3, 2, invisible 1. Both of these answers are correct and they mean the same thing, but this is a more formal answer. Here is number 6. I'm going to start by copying down our first polynomial. We have n to the third power minus 2n squared plus 8n. I'm going to stack up the pieces that look alike. We've got 8n to the third power matches with n to the third power. 5n matches with our 8n, so I'm going to stack those up. And our negative 7n squared matches with our negative 2n squared. Always remember to include the sign that's in front of the term. Now I've stacked up all of the pieces that look alike, and I can add these up straight up and down. I do not see a number in front of my n to the third power, so it's an invisible 1. 1 plus 8 gives us 9. Next, I've got negative 2 plus negative 7. Those have the same signs, so we can add the integers together. 2 plus 7 gives us 9, and then they're both negative, so we do get a negative 9. We will write negative 9n squared. Finally, 8 plus 5 gives us 13. So here's our final answer: 9n cubed minus 9n squared plus 13n. Here's 2 more problems to practice. I'm going to start by copying down my first polynomial. We've got 5n to the fourth power minus 7n minus 5n squared. I'm going to stack up the pieces that look alike. 8n to the fourth power matches with 5n to the fourth power. Our positive 3n matches with our negative 7n. And our negative 5n squared matches with our other negative 5n squared. So those look alike. Now that I have stacked up my like terms, I can add them together. 5 plus 8 gives us 13. Negative 7 plus 3. These have different signs, so we subtract the absolute values. 7 minus 3 gives us 4. And then our higher absolute value was negative, so we do get a negative 4. Negative 4n. Last up, negative 5 plus negative 5. They have the same signs, so we add the numbers. 5 plus 5 is 10. And they were both negative, so we get a negative 10. Negative 10n squared. So this is a correct answer. If you were working independently, your answer might look different from mine, but the important part is to remember that the signs and the integers must be correct, but they can be in any order. So here's another way that you may have written your answer. 13n to the 4th power minus 10n squared minus 4n. Here's one last addition problem. I'm going to start by copying down our first polynomial. 4x to the 3rd power, or 4x cubed, plus 8x squared plus 8. I'm going to stack up the pieces that look alike. I notice that 6x to the 4th power does not have a match, so you can either put it at the end here, or you can put it at the beginning. I'm just going to write it at the beginning of my polynomial and make sure that it has its own column. It's all on its own. Our positive 5 does match our positive 8. Finally, our 5x to the 3rd power does match our 4x to the 3rd power. So now that I've got all of the pieces that look alike, I can add them up. 6x to the 4th power did not have a matching like term, so that just comes down to my answer all by itself. Here, 4x to the 3rd plus 5x to the 3rd gives us 9x to the 3rd. 8x squared did not have a match, so it comes down to our answer all on its own. And finally, 8 plus 5 gives us 13. So this is our final answer. It's already written in descending order, going 4, 3, 2 in our exponents. Next, we will practice subtracting polynomials. Subtracting polynomials uses a lot of the skills that you just practiced when you were adding polynomials. We just have one new step that we'll do at the beginning of our problem. We will use the phrase keep, change, change to make a subtraction problem an addition problem instead. The rest of the steps are the same. Once we rewrite our problem as an addition problem, we will look for our like terms and we will stack them up together and add. First, we'll use the phrase keep, change, change to turn this into addition. So we are keeping the entire first polynomial. We keep that the same. We will change the sign in the middle. So we're going to be changing from a subtraction sign to an addition problem. And then what's very important is that we change all of the signs in the second polynomial. Instead of a positive 2y to the 3rd power, we have a negative 2y to the 3rd. Instead of a positive 8y, we'll have a negative 8y. And instead of a negative 2, we'll have a positive 2. Now that we have changed our problem into an addition problem, we can stack them up just like we practiced before. 3y to the 3rd power matches with negative 2y to the 3rd power. Negative 5y squared does not match with any pieces in our second polynomial. So you can see that I actually used a placeholder this time. I wrote 0y squared since there wasn't a y squared term in our second polynomial. But you can leave it blank just like we practiced. Just make sure that you're leaving some space under our negative 5y to the second power since it did not have a match. Our 9y matched with a negative 8y. Those both have just a regular variable. And then finally, negative 10 matches with a positive 2. Those are both regular integers without variables. So now that we've stacked up the pieces that look alike, we can add just like we practiced earlier. 3 plus a negative 2, we can think of that also as 3 minus 2, and that gives us an invisible 1. Negative 5y squared, remember this is just a placeholder that I wrote. You can think of it also as a blank, so that just comes straight down to our answer. Positive 9 plus a negative 8 gives us an invisible 1, y. And then finally, a negative 10 plus 2. Those have different signs, so we subtract the numbers. 10 minus 2 gives us 8. And our higher absolute value was negative, so we do get a negative 8 as our final answer. We will practice a few of these subtraction problems together from start to finish. So taking a look at number 1, I'm going to start by saying keep, change, change, so that I can rewrite my problem as addition. So we are keeping the first polynomial, 6r to the fourth power minus 8r to the third power. We are changing from a subtraction problem to an addition problem. And then I need to change all of the signs in my second polynomial. Instead of a positive 7, we need a negative 7, r to the fourth power. Instead of a negative 4, we need a positive 4, r to the third power. And now that we have both of our polynomials written into our addition problem, we can stack them up just like we practiced with addition. I'm going to copy down my first polynomial, 6r to the fourth power minus 8r to the third. I'm stacking my negative 7r to the fourth with my 6r to the fourth. And then our 4r to the third matches with our negative 8r to the third. And now I can add these up. These have different signs, so we can subtract the numbers. 7 minus 6 gives us 1, and our higher absolute value was negative. So it's like a negative invisible 1. We can write negative r to the fourth power. Next, we have negative 8 plus 4. Again, they have different signs, so we subtract the absolute values. 8 minus 4 is 4. And our higher absolute value was negative, so we do get a negative 4. So this is our final answer. This is like a negative 1, so we have negative r to the fourth power minus 4r cubed as our final answer. We will follow the same steps on number 2. We see another subtraction problem, so we start by saying keep, change, change. So we keep that entire first polynomial. We change from a minus to a plus in the middle, and then we change all of the signs in the second polynomial. That's how we will rewrite our addition problem, and then we'll work through the same steps that we've practiced. So I am keeping this first polynomial exactly the same. I'm changing from a minus sign to a plus sign in the middle. And then I'm changing both of the signs here. Instead of a positive 4a squared, I'm going to write negative 4a squared. Instead of a positive 3, I'm going to write negative 3. Now that I have my problem rewritten as addition, I can stack up the pieces that look alike. So I'm copying down my first polynomial, 2a to the 4th power minus 4a squared. And I need to rearrange the pieces so that they stack up the ones that look alike. Our negative 3a to the 4th power matches with our 2a to the 4th power. Our negative 4a squared matches with our negative 4a squared. In this problem especially, it was really important to include the sign along with its term. So that's how we ended up with our negative 3a to the 4th power. Now that we have matched up our like terms, we can add these up. 2 plus a negative 3. They have different signs, so we subtract the numbers. 3 minus 2 gives us 1, and our higher absolute value was negative. So this is like a negative 1. Our 1s in algebra are usually invisible, so I'm thinking about negative 1 a to the 4th power. Next up, negative 4 plus negative 4. They have the same signs, so we add the numbers together. 4 plus 4 is 8. And since they are both negative, we do get a negative 8. So negative 8a to the 2nd power. Here is number 3. We will always follow these same steps every time we see subtraction. I'm going to say keep, change, change to turn it into an addition problem. We always need to remember to change all of the signs of the terms in your second polynomial. So I am keeping our first polynomial, 3 minus 4n squared. We change from a minus to a plus, and we change the signs in our second polynomial. Instead of a positive 4n to the 4th, we will write negative 4n to the 4th power. And instead of a negative 4n squared, we will write plus 4n squared. Now that I have rewritten my addition problem, I can stack up the pieces that look alike. I'm going to start by copying down my first polynomial, 3 minus 4n squared, and then I'm going to look for matches and stack them up. I notice that I've got a negative 4n to the 4th power, and that does not match anything from my first polynomial. So that's going to go all on its own. You can either put it in a column on its own in the front, or you can put it in a column on its own in the back. This time I'm just going to choose to put it in the front. So negative 4n to the 4th power. Next, I see that my positive 4n squared does match my negative 4n squared. So I'm going to write plus 4n squared here. Now that I've stacked up my like terms, I can add them up. Our negative 4n to the 4th power was all alone, so it's going to come straight down to our answer. Negative 4n to the 4th goes straight down. Our 3 was all on its own, so it's also going to come straight down to our answer. And I'm going to put a plus sign in between since it was a positive 3. Finally, as I look at our n squared, I notice that negative 4 plus 4 gives me 0. So you could write it like this, 0 n squared, but this whole thing just means 0. 0 times anything at all will always equal 0. This really can disappear in our final answer since it means 0. My final answer will just be negative 4n to the 4th power plus 3. Here is number 4. Every time we see a subtraction problem, we will start by saying keep, change, change. Making sure that we change all of the signs in our second polynomial. So I'm going to keep our first polynomial. We've got 8n to the 4th power minus 6n squared minus n. We are changing from a negative to a positive. So instead of subtracting, we are changing to addition. And I'm going to change all of the signs in the second polynomial. This is also called distributing the negative, so you may have heard that before as well. So I've changed every sign. Instead of a positive 4n to the 4th, I made a negative 4n to the 4th. And instead of a positive 6n squared, I made a negative 6n squared. Now that I have changed it into addition, I can stack up the pieces that look alike, and I can add. I'm going to start by copying down my first polynomial. And I'm going to stack up the pieces that look alike. I notice that my negative 8n matches with my negative n. Those both have the same variable. My negative 4n to the 4th power matches with my 8n to the 4th power. And my negative 6n squared matches with my other negative 6n squared. Now that I've stacked up the like terms, we can add. 8 plus a negative 4. Since they have different signs, we subtract the numbers. 8 minus 4 is 4. Our higher absolute value is positive, so it is going to be a positive 4. Next up, we have negative 6 plus negative 6. They have the same signs, so we add the numbers together. 6 plus 6 is 12. And since they're both negative, it's going to be a negative 12. Finally, I do not have a number in front of this n, so it's going to be an invisible 1. Negative 1 plus negative 8 gives us negative 9. So here's our final answer. 4n to the 4th power minus 12n squared minus 9n. Here is number 5. So every time we see subtraction, we always start by saying keep, change, change. We are turning it into addition. So we keep the entire first polynomial, change from a minus to a plus, and then we change all of the signs in the second polynomial. So I am keeping my 4n plus 3n cubed minus n to the 4th power. We change from subtraction to addition, and then we change all of the signs here. Instead of a positive n to the 3rd power, it will be a negative n to the 3rd power. Instead of a positive 6n to the 4th power, it will be a negative 6n to the 4th power. And instead of a negative 2n, it will be a positive 2n. Now that we have changed the entire thing into addition, we can stack up the pieces that look alike. I'm going to start by copying down that first polynomial, 4n plus 3n to the third power minus n to the fourth power. I see a negative n to the third power. That matches with our positive 3n to the third power. Those are like terms because they have the same variable and the same exponent. So here's my negative n to the third power. My negative 6n to the fourth power matches with my negative n to the fourth power. So here's negative 6n to the fourth. Finally, our 2n matches with our 4n. Now that I've found all of the pieces that look alike, I can add them. 4 plus 2 gives us 6n. Here is a 3 plus a negative 1. I did not see a number, so I know that it's an invisible 1. This is like saying 3 minus 1, or you can say 3 plus a negative 1. That gives us a positive 2. Finally, another invisible 1. Negative 1 plus negative 6 gives us negative 7. I am going to rewrite my problem so that it has the exponents in descending order. So negative 7n to the fourth power plus 2n to the third power plus 6n is a more formal answer. Both of these are correct. Finally, let's try out number 6. This is our last subtraction problem. Every time we see subtraction, we say keep, change, change. So I'm changing all of the signs on the second polynomial so that I can rewrite my problem as addition. Copying down the entire first polynomial, changing from a minus to a plus in the middle, and then changing all of the signs here. Instead of a positive 4, it's going to be a negative 4. Instead of a negative 4r squared, I'm going to write plus 4r squared. And instead of a positive 3r cubed, I'm going to write a negative 3r cubed. Now that I have rewritten my problem as addition, I can stack up the pieces. So I'm copying down the first polynomial, 4r cubed plus 5r to the fourth power minus 8r squared. And now I'm looking for pieces that look alike. I notice that my negative 4 does not match with anything. I do not see any integers that are all on their own from our first polynomial. So I'm just going to put that at the end here, all on its own. You can choose to put it at the end or at the beginning. It doesn't really matter. Next, I'll put our 4r squared under our negative 8r squared. So that's a positive 4r squared. Our negative 3r cubed matches with our 4r cubed. So here is negative 3r cubed. Now I've stacked up all of the pieces that look alike, and I can add them up. These have different signs. I see a positive 4 and a negative 3, so we say different signs subtract. 4 minus 3 gives us 1. So we've got an invisible 1 in front of our r, and we can just write r to the third power. In the middle here, Our 5r to the 4th power did not have a match, so I can bring it straight down to our final answer. So positive 5r to the 4th power. Next, we've got negative 8 plus 4. Those have different signs, so we can subtract the numbers. 8 minus 4 is 4, and our higher absolute value was negative, so we do get a negative 4r squared. And finally, our negative 4 was all on its own, so it comes straight down to our answer. So this answer is correct, but we can write it in a more formal way by having our exponents in descending order. So we can write 5r to the 4th power plus r cubed minus 4r squared minus 4. Those exponents are descending, 4, 3, 2. Both of these are correct answers. Our second answer was a bit more formal. So thank you for practicing with me today. I hope that helped you out. And if you have any questions, you can either ask me or ask your instructor. Have a great day.